hitting the record. And I will share my screen. Okay. You should see now window with GitLab file sources. Okay, so the question for which we are meeting today was how jobs are being scheduled to the runners. Yeah. First thing that needs to be remembered is that it's always runner that starts the communication. It's not GitLab. We have now the CI web terminal where GitLab starts some requests. This is a little change in the general architecture. But for a very, very long time, there was no communication from GitLab to the runner. It was always from runner to GitLab and then getting something in the response. Now with the first request for a job, we are sending information how you can access the web terminal. So there is a way for GitLab to connect back to the runner, of course, if it is configured properly. But this we will not look on this time. Okay. For scheduling jobs, updating the trace, updating the job state, we can just assume that it's always GitLab runner that sends a request to GitLab. First, very briefly, let's look into the build model. We don't use build name now in GitLab CI terminology. We use the job, but in the model it is still named the build.
So sorry, the build and jobs are equivalent?
Yeah, at the very beginning, GitLab CI was managing builds.
Okay.
But at some moment, we decided that build for someone may show the wrong context because it may suggest that it is all about building something. So compiling, building images, and it's GitLab CI. It doesn't limit you to only do this. You can do in this script anything that you want. You can deploy something. You can create something. You can do some tests. And at some moment, there was a product decision that will rename build to be a job, because job is more generic word, more generic description of what this part of CI is. But in both Rails and runner code base, the build word was used in so many places that it's still left. Especially the model is named build because the table in the database when it was created was named CI builds. So in the documentation, in any written artifacts that we provide outside, we talk about CI pipelines and CI jobs, but inside of the code base, if you want to see something about the job, you will in most cases want to look for the build word in many different
yeah, I found it in fact that confusing, and I didn't know exactly what build mapped to pipeline sometimes or jobs.
Yeah,
makes sense now.
Build is definitely the job.
Okay.
It was just not renamed in the code. Not focusing now what is the lifetime of the job. We had such discussions a few weeks ago, and I hope we will have some documentation created from this soon. What needs to be known for the scheduling is that the jobs have different states. And the scheduling for the runner happens only for jobs that were transited to pending state. So the GitLab is creating a job when it is creating the pipeline, and the job may be started by few things. It may be a job that is just started because it doesn't have any special configuration and it's in the first stage. It may be a job in a not first stage of the pipeline. So then the job is created and it waits until GitLab decide that the first stage is finished, and then it starts all of the jobs from another stage. And we have manual jobs where you need to manually click the start button or do an API call to start the job. What this start?
Sorry, can you repeat that? Sorry, can you repeat again? So what? So originally the job is in created state.
Yes.
And then when does it transition into pending?
Because we create all of the jobs for a pipeline at once when creating the pipeline. Mm-hmm. And when you have a pipeline that is running, you can see this graph where some of them are not working. Mm-hmm. They are waiting. It's not only the graph that prints what jobs will be. The jobs are already created. The objects are stored in the database. All of the connections are made. Just the jobs are in the created state. Okay. And now to start a job, it may be done by three things. First, you can have a manual job, which needs to be explicitly marked as manual. And you need then to either click the start button in the UI or use API to start this job. Second thing is that when the job is not in the first state, not in the first stage of the pipeline, it will be started by GitLab automatically when the previous stage of the pipeline will be finished. Then GitLab is transitioning the state of the stages in the pipeline, and it starts all of the jobs from the new stage. And the third option is when the job is not manual and it's in the first stage or the only stage in the pipeline, and then it is just start at the pipeline start. And what starts does, it transitions the job to the pending stage. And this is for us important in context of job scheduling, because scheduling jobs for runners is working only with jobs that are being in the pending state.
Oh, I see.
Nothing else.
Yes. Because if everything was in created, then potentially we could assign jobs there farther down the line. Okay.
For example. Second thing that is important to remember is that most of the logic of CI is implemented in the Rails app. Or I always say that runner is a little stupid binary that has only one job. It gets a job definition, it executes it, and it reports the state. Nothing else, nothing complicated. It, of course, has some own logic about how the executors are configured, how the job may be executed in different things. But from the context of CI, most of the business logic is implemented in the Rails app. And especially the scheduling part is implemented in Rails. So knowing that we are working only with jobs in pending state to think about scheduling, let's look how the scheduling works. I said that it is runner that starts the communication, and it does this with the special API that we have for runners. When you look into lib API, we have runner.rb file. This file contains the API used by GitLab Runner to work.
Okay.
Second, runners, it's the API served for the user.
Okay.
So you can get information about your runners. You can pause the runner, unpause the runner, do a lot of these things. And this is mostly prepared to be used by the users of GitLab. And we are interested in the runner.rb because this is the definition of the API that runner uses. So registration of new runner, requesting a job, updating the patch trace, downloading and uploading artifacts in context of job, not in context of user usage. Okay. Everything goes to this API. And we are interested in this endpoint. So
okay.
runner sends the request to the address that looks like this. Let's just use gitlab.com as GitLab version, as GitLab installation. API v4 jobs request, and this is the post HTTP request. With this, we are sending token that authorize the request. This is the token that is unique for every GitLab runner registered inside of GitLab.
Would it be equivalent of the registration token?
No, registration token is used to register the runner. So you have registration token on the level of GitLab, the instance level, on the level of each groups, and on the level of each project. And registration token is used only this one time when you register a new runner. The runner shows this token. GitLab then knows that this is the authorized request and to what it is authorized. So you try now to create a runner for the instance level or for the project level or for the group level. In case of group and project, it finds which group or which project to connect this runner to. And when the runner is registered, when it is connected to the instance group or project, it retrieves its own unique token that is saved in runner's configuration file. And this token is next used to authenticate requests for new jobs. And only this. Oh, no, because we have also some API to checking if the runner is still installed in GitLab. So there also this token is used. Because next, updating the job, downloading, uploading artifacts, this is done with the CI job token, which is unique for each job, and it's valid only when the job is in the running state. So with this token, we are authorizing the request for new jobs. Last update, this is used to there is a little caching around this endpoint because we have a very lot requests. By default, GitLab Runner will request GitLab each 3 seconds for new jobs. And last year in April, when I was checking this, we had 16,000 runners each day connecting to GitLab. Each of them was creating at least one request per 3, 10, 30 seconds. So we have a huge amount of such requests only for gitlab.com. So we have some sort of caching on the level of the Rails, on level of workhorse, which is the proxy. And this field is used to connect all of these three parts and to decide if we need to send a response or not.
Yeah. I've seen that it returns 3 or 4 every now and then from the logs.
Yeah, let's not focus on this right now. You can find where this last update is used here in this endpoint. You can look a little through GitLab workhorse. If you will need help, we can just jump to this together and go through workhorse code to see how the API is configured. For now, let's just know that we on GitLab Rails and GitLab Workhouse side, we are limiting the number of requests and queuing it a little to just make the database and the system less hammered by the request.
Okay.
With info, we are sending some metadata about the runner, what version, what configuration it has. And with session, this is this new thing, we are sending information how you can connect with the CI web terminal to this.
Okay.
Going fast forward, if runner will be authenticated properly, if it will be not outside of the limits of the last update, everything that we check here for preventing requests that could affect the system stability, we enter this line.
Okay.
There is a register job service which contains the scheduling algorithm. When it returns a job, or not a job, it returns a result that may be valid or not. It can contain a build, a job, or it can contain information that for this runner we don't have a job. And based on this, we are sending one of these three responses. And in case of this one, this is the payload that runner will receive and start executing a job.
Okay.
So to see how the job is scheduled, we need to see the register job service. And here in the execute method, again, I will not now describe how services are working in the Rails app of GitLab. For now, we need to know that this execute method, this is something that is being executed to handle this request. So at first, in the API, we authenticated the runner, and while authenticated the runner, we found what runner this is, exactly which one runner registered in GitLab. This is passed to the service, and here we are checking what type of the runner this is. Because for instance level, so the shared runner, we have one query to the database. For group level, we have another query. And the only left case is the project level runner, where we have also separate query. Because jobs query is stored in the database. And this is recognized by the pending state of the job.
Okay.
So we are executing one of these three queries, the basic queries, that are next additionally checked against the tags, the runner tags. And this step here checks if the jobs, the list of jobs that we initially taken for the runner that is asking, if we have any jobs that are matching the tags specified for the runner. Do you know the tags field in the GitLab CI/YAM file?
And I've seen the tags when we register a runner, but I don't know how that interacts with other tags.
You can tag each runner. For example, I think all of our shared runners on GitLab.com are tagged with the Docker tag.
Okay.
And then in your GitLab CI/YAM file, for each job, you can specify a list of tags that needs to be present on the runner to make it possible to run this job. This is the way how you can define which runner should execute which job. Okay. Let's assume that you have a project where the test may be executed on any platform that you want. But the binary can be built only on Windows machine. So in case of GitLab.com, we don't have Windows shared runners. We have only Linux-based shared runners.
I see.
And in your project, you can just decide that you don't want to manage your own runner for this. You just want to use the shared runners that GitLab.com provides to execute some tests. So you can just do nothing. Shared runners on GitLab.com are configured in a way that they will execute each job that doesn't have tags. And if you have the shared runners enabled in your project, they can take this job and execute it. But for the compilation, your project requires that it will use the Windows machine. So you add the Windows machine to your project. But now, if you have this Windows machine there, it may start catching some of the jobs that it should not. So you add a Windows, to this Windows runner, you add some tag, for example, Windows. And in the job of compilation, you add this tags array where you specify Windows. And the rule is that the runner needs to have at least all of the tags that you specified for the job to execute this job. So if you have a runner which is tagged with Linux, Docker, Ubuntu, and in your job you specify a Linux tag, it will work.
Okay.
But if you have a runner that is tagged with Linux, but in your job you specify Ubuntu, Linux, and Docker, then this will be not executed on this runner because this runner still misses the two tags that you require to have for this job.
I see. Okay.
So this is how tags are helping you manage which runner should execute which job, and this step here from the initial list of jobs listed for the specific runner gets only these jobs that are matching the tags of the runner that we are working with. And this is what makes that if you don't have any available runner with such specific tags, no job will be this job will be not taken, and at some moment you will see in the UI that the job is stuck because you have no runner with tags, and there is a list of tags listed in the notification. However, we have also the case where the runner may be explicitly configured that this runner executes any job that doesn't have tags specified. And this is how shared runners on GitLab.com are configured. You can check what tags we provide there and set them for your jobs, or you can do nothing and just make sure that the shared runners are available. But for some other runners, we have this option disabled. So this runner will handle only jobs that are matching with the tags. If the job doesn't have tags, this rule removes the job from the list.
Okay.
Can pick on the runner does more or less the same. We will look at the end on this method what it does, because here we have the final list of jobs that should be able to be executed on the runner that requested a new job. So we are iterating over this list and taking the first one which can be picked and assigned to the runner. In case of a race condition where two runners requested a job in almost the same case, two runners were so equal that the same jobs were taken into the list, and two runners would take the same job at the first one. We have the transactions, and the first one which will in the milliseconds win this competition will obviously lock the transaction, be assigned, update the state to running. The second one will receive one of these two exceptions.
I see.
And in this case, to just speed up the thing, we are allowing the loop to be executed once again. So if we had an exception only because there was a race condition, we try to assign the job, another from the list, to this runner to just not require another request made. In case if such situation would be repeated, we return an error, and then the runner need to do a request again. So let's maybe look on this can pick. It basically checks against the protected feature, because you can mark some tags and branches as protected in the project.
I see.
And in that case, the runner needs to be maybe no, in the opposite thing. If you mark the runner as protected, then it will execute only jobs on the protected branches and tags.
Oh, I see.
So you can have, for example, a runner that is doing production deployment, and you don't want anyone with access to the project to be able to start this job. You want to only have some users that you trust to be able to do this. So you make them maintainers in the projects, then they can start jobs on the protected branches and tags, which will be running on the protected run.
Okay, yeah, makes sense.
In very short, how this works.
Yeah.
Accepting tags and as enable for is again checking if the tags requirement is met, because here we will remove jobs that have no tags matching to the runner, but this still leaves us with not quite sure situation if the job is ideally matched to the tag runner tags. So the as enable for we'll check this, and then it is also checking against groups and projects, because if you have a group runner, then it should be available for all subsequent groups and projects. So these are some checks additionally done to just make sure that the runner requesting for this job is just allowed to execute this. And now looking on these three basic queries, the most simple is the project one. So if the runner is a project runner, we get the list of projects assigned to this runner. We are removing from it all projects that are pending deleted, and all projects where the pipelines feature is not enabled. We then get a new builds. It's also what we need to look on, because we are looking on pending and unstarted jobs. And in case of the protected runner, we are looking on also on the jobs that are marked as protected. And then in case of projects, we additionally limit this by the projects for which the runner is assigned. And we are ordering the jobs in ascending order. So the first one in, the first one assigned.
Okay, yeah, makes sense.
Yeah, on the group level, the query is a little more complicated because we need to get groups hierarchy and check and list jobs from all projects from all groups and subgroups for which the runner is assigned. And then again we are ordering this by ID. This is a rule that is repeated in all cases. So when we do all of the checks, so if the tags are matching, if the protected is matching, if for the instance level, in a moment we will look on the first scheduling algorithm. If this first scheduling is matching, we finally have a list of jobs that is ordered by ID. So we are assigning from the oldest one. Mm-hmm. And now I've mentioned about the first scheduling, which is done for the instance type of the runner, so the shared runner. And if you will check this query, analyze what it is doing, we basically prioritize jobs from projects that are at this moment not using shared runners. For example, you have a project and I have a project. You pushed something that created 1,000 of jobs, and the shared runners that we have on our GitLab instance is able to execute only 10 of them at once. And now I push something that creates one job. And if we would not do this first scheduling, but only handle jobs in the order of their creation, I would need to wait for all 1,000 of your jobs to be finished until my will be executed. So here we are trying to make this distributed more evenly between the projects. So if your project at this moment doesn't have any job running on the shared runner that is asking for the job, you are moved up in the list. If you have some jobs, then you are put it in the list depending on how many jobs you already have on the shared runner. And then in this list, we again order this by the ID of the jobs. So if you push it 100 of the jobs and I push it 10 of the jobs, in very simple scenario, it should be done like GitLab will assign for every query from the runner, it will assign your job number 1, my job number 1, your job number 2, my job number 2, your job number 3, my job number 3, up to 10. And then because you have still jobs, I have no jobs left, and there is no other jobs in this GitLab, it will be able to assign your job number 11, 12, 13, 14, and so on. And so on. So this is how we try to make usage of the jobs fair among all of the projects when they are using the shared runners.
Okay.
we are not doing this on the group level and on the project level. We just assume that when you have this for your groups, you don't fight against this resource because this is your resource. For the shared runners, we want to make it available for all users on the GitLab instance. Mm-hmm. So this is how this is implemented. Here we have also some metrics that are tracked during the job scheduling. And what needs to be remembered is that it's runner that creates the request and asks for a job. If you will disable all runner, maybe not disable, if you will have some network problem that will make runner unable to communicate with GitLab, you will have a growing pending jobs query, because no one is asking for jobs, no job is being scheduled. After some time, there is a worker where we have workers not CI, it was stacked CI jobs worker. This is a worker that will at some moment decide that your job is stuck.
I see. Okay.
And it will drop it with a proper error message in the job. So if there is no request from runners, no jobs are scheduled, because this is the basic requirement. There needs to be a runner that will ask for a job. Mm-hmm. When the runner is asking for the job, we are first checking which type of the runner this is, and then we are creating a basic list of jobs dependent on what runner asked for it. In case of shared runner, we are trying to fairly distribute this among all of the projects. Next, we are checking if the tags are matching, if the protected is matching, if the group project is allowed in this case. And we are limiting, filtering all of the jobs that are not meeting the requirements, putting them off. And then we have the final list of jobs ordered from the oldest one. And we are trying to schedule for this request the first one from the list. But in case when you have more than one runner, it finally ends that you have the assigning quite random. If you have in your project few shared runners that are enabled and are matching all of the requirements for the job, and if you have additionally few project level runners that are also matching this job, and you have few group level runners on different groups that your project belongs to. If you have these 50 runners, for example, and each of them is able to handle this job, it will be assigned totally randomly, because you can't say which one of the runners will be the one that will ask for a job in a moment when this job will land at the top of this final list and be assigned. Okay, so I think I said everything I wanted to say. I showed you all 4 files that I think are important here.
Yeah, I think it's very, very clear, and I might need to dig more in detail to digest better the queries. But regarding the, something we are recently discussing about pre-assigning jobs to a runner, as if we want the key use in the workspace, yes. So that means that rather than assigning the first, like register success and then return the result, we might need to do something there where actually we don't exit the build, but we try to schedule all the possible jobs we can give to this runner? It can be a little bit complicated, I guess.
Yes. That's why I said that working on the workspace issue will not be only a runner thing. It also needs to be done on the Rails side, because this change how jobs are being scheduled and assigned to the runner.
Yeah.
When you will look on the workspace issue, there is in the discussion, I've mentioned this, and then Kamil proposed that in that case we could start preparing separate queries for such jobs. This is one of the ideas. Maybe we'll find a better one.
Yeah.
But this will be definitely need to be changed if we will start working on this.
Yeah. So yeah, it looks like that we will have, if I understand correctly, like scenarios where the jobs, apart from the one that can currently be handled by the runner, that will be the only one pending, we have other jobs down the line that will be still in created state, but somehow are already assigned to a runner. So that next time when the runner finishes the first job, requests the next job, it will simply trigger a change in the state machine from created to pending, but it will, or we already know that is already be pre-assigned to that runner.
No, don't mess the states. The created to pending is done by GitLab, and yes, this is what needs to be done to even make this job visible for the runner. Runner, when requesting for job, is transitioning the job from pending to running.
Yeah.
So finally we will have a list of jobs in pending state that are already assigned to some runner, not in created.
Okay, I see.
Because if job is in created state, the runner will not get it, because
I see.
The job is only created. So transitioning from created to pending will be happening like it's happening now. When the job is manual, you will need to trigger this by hand, API or by the button. When the job is not manual, then in the first stage it will be started automatically. Mm-hmm. In each next stage, it will wait until GitLab will decide that the first stage, the previous stage, was fully finished. Mm-hmm. There is no failures that are not marked as allowed to failure, and it will start another stage.
Yeah, so in that case, we'll change the next job from created to pending.
Yes.
That allows that job to be queried for the scheduler.
Yes, and what we will need to change in case of the workspaces work is that this pending will need to be assigned in a different way that we have here for the default case, because this will need to be assigned to the one specific runner to make it able to reuse the workspace.
Yeah, so but it seems like we can't change all the jobs that could be assigned for a specific workspace. They're all part of the same workspace. We can't change them all into pending at one time, because we might risk to pick jobs that are later down the line and assign to the runner, right? While we want to still have a kind of a sequence of the events.
Yes, and that's why we talked last time that at least for now, the workspaces will not work for the parallel jobs. Because in case of parallel, we still need to make this something somehow sequential. So finally, we will need to I don't know how we will just go with the workspaces issue.
Yeah. I was trying to figure out. Like,
there are two possible ways. We allow you to configure multiple jobs in one pipeline stage, but then we'll need to get them and order them sequentially. So you have 100 parallel jobs that are executed sequentially.
Yeah.
The other case is that we will not allow to create 2 parallel jobs assigned to the same workspace at the same time. But this is a different level of how we will handle the workspace. From the runner side, what we will need to change in the scheduling part is that we will need to pull these jobs out from the general queue and create some sort of query specific for the runner and workspace pair. So jobs specified for this workspace can be executed only on this specific runner, which was the first one that handled this workspace. And then for this, we will need to have a separate query, and we will need to update this mechanism to somehow recognize that this runner asks for some job that may be in this specific query.
Yeah.
So this will be the challenge that we'll need to resolve.
I see. Well, it's been very enlightening. So thanks for your time. If I have any questions, I'll definitely will dig more in details and the queries and everything. And if I have any questions,
Sure.
I'll let you know.
Sure. In a moment, I will send you the documentation page where the first scheduling algorithm is described. So
okay.
When looking on the query and on the documentation description, it may be a little easier to understand the query. The query, when you will execute this on your local GitLab development instance, the query is the analyze from Postgres is loop in. It has 4 or 5 levels of nesting.
Wow.
So the query is really complicated, and looking on the documentation that describes how this should work, for me, made it easier to look on the query and understand how in fact this is working.
Yeah. Makes sense.
Okay.
Cool. Thank you very much. If you manage then to send the recording, I'll probably go through it once again if I miss anything.
Sure.
Thank you very much for your time. Okay.
Yeah, sure. See you later.
Yeah, see you later. Have a good day.